All right, so good morning. I just wanted to do a few examples from the greatest common factor section, just in case some of you guys were having trouble yesterday. Maybe this will be helpful to kind of see a few problems worked out. So like I said, the biggest idea what a greatest common factor is basically the biggest thing that divides into both of these terms or pieces, or in other words, it's like what they share in common. Like what do these two things have in common? So if you have a question like this first one, we have 18x squared and 48. Since only one of the pieces has an x, we're not going to be able to pull out a variable. So we're focusing on our numbers, like what divides into 18 and 48. And some of you guys might be able to just kind of see it from there, like, oh, the biggest number that would divide into both of those is this. If you're good at finding like a common denominator, that might be something you're able to see. But if you struggle to see that, what you can do is kind of do a factor tree. So this should look a little bit familiar, probably maybe way back to middle school. I would think you probably do these. But you just want to think of numbers that multiply to what's above it as you're breaking this down until you get to something called prime numbers, or numbers that can't be broken down anymore. So like, for example, what multiplies and gives me 18? Well, 9 and 2. You could also do 6 and 3, as long as it's true, like it's all good. And then 9 would be 3 and 3, which these are prime. You can't break these down. You never want to put like 1 and 3 or 1 and 2. 48 we could break down as 2 and 24. There's also other factors you could start with. That would be 2 and 12, 2 and 6, 3 and 2. So if we want to look at what they have in common, and remember, once you break something down, actually, you're not looking at this 9, you're not looking at these 24, 12, or 6. Like once you break it down, you don't look at it anymore. But what we have in common is we have a 3 and we have a 2. And that's all they have in common, because there's not another 3 in the 48 tree, and there's not another 2 in the 18 tree. So what they have in common is a 3 and a 2. So 3 times 2 is 6. So our GCF is going to be 6. So your GCF always goes outside your parentheses, and then you divide each part by your GCF to see what goes in. So 18 divided by 6 would be 3. Bring down the x squared. 48 divided by 6 would be, what's that? 8. Sorry, I had a little bit of a brain fart there. So this would be our answer. And I mean, you could always multiply this back. You'd see where you get back. Like if you distribute, you'd see you get back to where you start. You're kind of undoing the distributive property in a way with these questions. Let's look at another one though. And these questions are coming straight from Delta Math. So hopefully this helps. All right, so for a question like this, we have 3x, we have 7x squared. We want to see what they have in common. Well, first off, 3 and 7, you can't break these down. These are called prime numbers. Like the only thing that multiplies to 3 is 1 and 3. The only thing that multiplies to 7 is 1 and 7. So in terms of numbers, we're not really going to have anything in common, or they have a 1. But we want to look at the variables. I mean, x is just x. But remember, x squared is really like 2 x's. So really all they have in common is a single x. And if you want, you could put like for the number part, they have a 1 in like 1 divides into both of these. So our GCF is going to be 1x. So we're going to divide everything by 1x. And how I like to think about this, I mean, first off, 3 divided by 1 would just be 3. Basically, when you divide variables, I like to think of it as you're taking away. So if when we divide by x, we're taking away 1x. So if we take 1x away from 1x, well, we don't have any x's left, or basically these would cancel. 7 divided by 1 is 7. If you had 2 x's, you take 1 x away, it would just be a single x. Okay. This next one we're going to see, we're going to be able to pull out a variable, and we're going to be able to pull out a number part. And some of you guys, like I said, you might see, oh, the biggest number that divides into both of those, it's 8. Maybe you see that. If you do, awesome. But if you don't, do a quick factor tree. Like, I mean, this would just be 4 and 2, 2 and 2, so we get 3 2s basically. If you start breaking down the 48, you could do 2 and 24, you could do 12 and 2, you could do 6 and 2, you could do 3 and 2. And your tree could look different than mine. Like you could have done different factors, but you should still see you end up with like the same things at the end, like these prime factors. So we want to see what they have in common. So if we look, we have a 2 in common, we have another 2 in common, and we have a third 2 in common. Like both of these trees have 3 2s in them, right? Like that's what they have in common. Then if we look at our variables, remember x to the 5th, that is 5 x's. X to the 4th is 4 x's. So I mean, really what they have in common is they have 4 x's in common. So 2 times 2 times 2 is 8. And then 4 x's is x to the 4th. So that's our GCF. So we're going to divide each one of these pieces by 8x to the 4th. So I mean, 48 divided by 8 is 6. You had 5 x's, you're taking away 4 x's, so you'd have 1 x left. 8 divided by 8 is 1. You had 4 x's, you took 4 x's away, so there's no x's left with this second piece. And that would be your answer. So like just a couple things to kind of end with. Like I said, you don't have to do a factor tree like I'm doing, like I'm breaking down these numbers to see what's in common. Like if you see, oh, the biggest number they have in common, it's 5 or it's 10, like you see it right away, then you don't, maybe you can save that step. But if you are struggling, this will always work. Like if you do a factor tree. And it's not that bad because most of the numbers you aren't going to have too big of numbers. I mean, honestly, this one's kind of like with the 48, that can be kind of a pain to break down, but it's not that bad. So I hope this helps as you're going through the Delta math. Please check progress book and make sure you're making up any missing assignments, but also try and work on finishing up this Delta math section. But feel free to email me if you have any questions or stop in for tutoring. I'll tutor in tomorrow, which is Wednesday, depending on when you're watching this video. But have a good one, everyone.